All right, welcome to the next set of videos. As I'm doing this, it's the weekend after, the Monday after Christmas, so happy holidays to everyone. But you'll see it sometime in January, so oh well. Okay, so arc length and curvature. Okay, so we already talked about some of the things we're going to talk about in another one of the videos, but let me just re-emphasize or rephrase it. So we've got, let's say we have a curve. Maybe a little too much eggnog last night. So let's say we have a curve r of t, okay? Then we can find the unit tangent. Okay, the unit tangent is given by t of t, a little bit, there we go, which is going to be the velocity of the curve divided by the speed of the curve, okay? We make it clear that's a vector. Okay, so we've got our unit tangent. We've got our unit normal. Our unit normal is going to be the derivative of the unit tangent vector divided by the length of the derivative of the unit tangent vector. Okay, so even though the unit tangent vector is a unit vector, that doesn't mean necessarily that its length, that its derivative is a unit vector. Okay, and then finally the unit normal or binormal. Okay, and so these vectors are actually, they are a convenient basis to use when describing what's going on for a particle in motion. Okay, so these are a convenient set of vectors. I said basis, but that word's not really in the Calc 3 vocabulary. Okay, but it's a convenient set of vectors to use to describe motion, particle motion. Okay, we also have a couple other things. We have what's called the curvature. Okay, the curvature, there's actually a bunch of different definitions. Let's go with first kappa of t being the magnitude of t prime of t divided by the magnitude of r prime of t. Okay, but that's actually equivalent to the magnitude of dt ds, where ds, okay, ds is actually the not the arc length, but the derivative of the arc length. So ds is actually that magnitude of r prime. It sure the heck is. Okay. So really, let me write it this way. S is the integral of the square root of x prime squared plus y prime squared plus z prime squared dt. Okay. All right. We also have another way to get curvature. Another formula for it is the magnitude of r prime cross r double prime divided by the magnitude of r prime cubed. Okay, so we're talking a little bit about what this curvature is, but so we're going to sort of do one of the things to remember is what is the curvature of, let's say, a circle? Okay. So a circle of radius r has curvature 1 over r. Okay, so let's go ahead and do that. So let's take our circle of radius r. We already know what are equations that are going to describe that. So x equals, let's say, r cosine t, y equals r sine of t. Okay, so we're going to write our r of t. We're going to assume it's in the xy plane. So r cosine t, r sine of t. We'll just add a 0 there. Okay, let's take and let's use, we're going to go ahead and use this definition. Okay, so r prime is going to be, well, the r is still going to be there, and it's going to be negative r sine of t, r cosine t, 0. Let's move this and make it blue. Okay, let's take r double prime. R double prime of t is then going to be negative r cosine t, negative r sine t, 0. So let's take, and we're going to use our curvature is magnitude of r prime cross r double prime divided by magnitude of r prime cubed. Okay, well, we already know, let's take r prime cross r double prime first. That's the determinant of this matrix, right? ijk along the top, we have negative r sine t, r cosine t, 0, negative r cos t, negative r sine t, 0. Okay, and actually the only one that gets anything is the k. One way to sort of think about that is that since r prime and r double prime are both in the xy plane, your cross product, remember, has to be perpendicular to it, right? So it has to be k. So k is the only thing you're going to get. And we're going to get r squared times sine squared of t plus cosine squared of t, r squared. Okay, so we're going to get here, oh, and that's in the k direction. Okay, so we're going to get r squared in the numerator, r cubed, that one's pretty clear. You're just taking the magnitude of this cubed. Okay, so that's going to be 1 over r. Okay, so a circle of radius r has curvature 1 over r. Okay, I'll see you all in the next video.